Hello, everybody. Welcome to the fourth Angular Belgrade Meetup. Today, we have two guests from Greece and Canada, Fanis and Bell. Fanis and Jay have done a lot for the Angular community in the last couple of years through the open source contributions, blog posts, videos, and talks. So first topic for today is, first talk is by Fanis. He will talk about lazy load Angular components. Kalispera, Fanis, and thank you very much for accepting my invitation to join us today.
Thanks for having me. So can I say Zdravo or is the wrong one?
Yeah, you can say Zdravo.
Okay,
or
yeah,
ciao.
So, Zdravo. So thanks for having me. Thanks for the invitation.
You're welcome.
So can I share my screen?
Yeah.
Okay, nice. So I'm sharing my screen. I have to prepare this as well. I think this is ready. No, give it some time. How can I use this? I forgot how to use my slides. So I have to go back. Sorry for this. Present. Nice. So this is what I was looking for. I want also to have my notes and full screen. And let's start.
Great.
Good luck. Thank you very much. So this is my card. So allow me to introduce myself first. My name is, like Marco said, my name is Fanis Prodromou. And I'm an Angular tech director and a senior instructor in the company Code.Hub. It's a private institute where we are located in, focusing actually in training with different technologies, and I'm responsible for Angular. I'm a front-end lead in the company ARCHITECHTS. I'm an author of the book Mastering Angular Reactive Forms, and you might be wondering, where's the book? So not yet deployed, not yet published, but very, very, very soon it will be not deployed, published. And I have also a free course in Angular Nation, and the title is Intro to Reactive Forms. So if you do not know Angular Nation, you should check it out. It has very cool content there, free content as well, and you can hang out with great people. And I'm also co-organizer of Angular Athens Meetup. And here you can see my contact details, my Twitter, my blog, and my LinkedIn account, and also my YouTube channel, Code with Fanis. So this is my my YouTube channel, Code with Fanis. I currently have some subscribers, and I have cool content there. And the idea of this YouTube channel is to focus mainly on problems and provide the solution. So it does not have that much theory, let's say. It's mainly how to do things. Some very popular videos is how to split an Angular Reactive Form into child components. This is based on a theory, how the difference between Angular ArcJS subject, behavior subject, replace subject, and stuff like this. So I think that you will find something good here. So check it out and please subscribe. So without any further delay, let's start. So today's talk is about how to lazy load a component. In order to guide you of how to lazy load a component, we will start with the very basics. And the first one is how to load a component using a selector. And you might think now that, come on, using a selector, we know how this thing works. I will try to make it not that boring for you. And at the same time, this is helpful for me in order to have a flow for the talk. The second part is how to dynamically create a component using a factory resolver. And last but not least, how to lazy load a component. And the template that we're going to work with for this talk is this great template. So this is my CSS skills, just kidding here. I have just a border and dashed border, and this is prominent. It says render your component in the dashed area. So our goal, regardless of using a selector, dynamically create a component, or lazy load a component, our goal is to present a component in the dust area. And this is how the template looks like. This is just plain HTML, no more than this. Just a div here, a paragraph tag, another div with some classes, and inside here, of course, we'll have to render the component. So the first thing is to using a selector, right? So how can we do this? And the question is, what is the outcome if we use this selector in this dust area? What will be the outcome? If we check the template, we will see that this is the content of the lazy load component, and we can see also that we have an inline styling here, color red. So we can see that we can say that as soon as we use this selector, I expect to have this outcome. And let's see also a demo, a very quick one. So I have different branches here, and we will start with a load component with selector. Allow me to save this. And I will close everything here, and let's see what we have in this application. So we have the app component HTML, and in the app component HTML, we have just a lazy wrapper component. Nice. And what is this all about? So let's go to the lazy wrapper. And this is just a very simple component, and the only thing that it has is a selector, lazy content. And this lazy content is this component here, where we have the selector name and the template. And we have one component very similar to this one, and the name is lazy one content component. And if you see, the differences are that we have here color red, whereas on the other one, we have color green. So these are the differences. So what we will try to do now is the following. Here we have the lazy content. Okay, let's go to the browser, reload, and this is what we can see, lazy load component. My question here is, how can we load using a condition more than one components? So what we can do is the following. For example, we can have here an input, and I will name it like type, and this will be a union type of lazy or lazy one, either this or the other. And then we can have a condition in the lazy content and be like, and if the type equals lazy, then expect to render this one. Otherwise, if the type is lazy one, I expect to load the lazy one content. And of course, since we have an input in this wrapper component, we have to inject this type from the app component HTML. So let's do this here. The type is going to be lazy. Go to the browser, and as we can see, we have here the red. Nice. And if we switch this to lazy one, we expect to see here the green one. Okay, so this is very, very, very easy. And my question here is, don't we see a problem? How about if we're going to load many components? Say that we're going to load 10 different components. The problem that we'll face is that we have a violation to open-close principle, and we will see later on what is the solution for this one. But this is a bit problematic. Before moving forward, let's see how things work. As we know, Angular should compile every component, every directive, every module. In general, Angular should apply a compilation. But what do we mean by saying compilation? What we can see here is a TypeScript. And of course, the TypeScript should be converted to JavaScript because browsers currently do not understand TypeScript. So we have to transpile this code from TypeScript to JavaScript. But apart from this, here we have just a class. And here we have a decorator component. And somehow during the compilation, Angular, what it does is that applies semantics to this class to say that, you know what, this code is a component. And this is how the compiled component look like. What we have is a factory, and we have also this weird character with CMP from component. If this would be like a directive, it would be the with character and dir from directive. And also we have the type. So let's focus on this one. This is very important. We have the selector, we have the template, and many things. And of course, I didn't have that much space for this slide. But what I want to focus on is that for every component, we have a compiled version. And keep in mind that we have a compiled component stack. Of course, I do not imply that this is the architecture that Angular has, but this is at least very helpful for me for this talk. And let's keep this for the rest of the talk. So every component has a compiled component, and we keep it in a stack. And if you are wondering how the compiled component looks like, the component that we saw previously, so this is how it looks like in the developer tools. What we can check is that we have lazy one, content component, we have the factory, and also we have here the CMP, and of course we have here the type, which is very important. Let's focus now on this infographic. What I'm trying to do with this infographic is to explain the flow. Think that we have a very simple template, and the template is just a div, an HTML div, and also we have a component selector. And this is the app1 CMP. Okay, so Angular, of course, does many things. We have the compilation, we have an AST, we have, in any case, a token generator. And from the tokens, based on this template, we're going to have two different nodes. And these are the app1 CMP and div. And the next step is that we should focus now, not on the div, but we should focus in the app1 CMP, in this one. So Angular now will try to grab the component from the compiled component stack using the selector. And as soon as we have this, we have also the template, and we can just publish it. Voila, we publish this in the browser, and everything seems to work fine. Nice. So this is a very simple flow of how things work. But again, the thing that I said previously is that we have a problem here, and the problem is how about if we want to load many components? This is a violation to open-close principle, which says that the code should be open for extension but closed for modification. And if we have 10 different components, we have to revisit the same code and again and again and again. The solution to this problem is to lazy load the components. The recipe for this is to use a view container ref and then dynamically create the component. Now, let's dive into the second part of this talk, which is how to using a factory resolver and dynamically load a component. The template is the same. The only difference is that we have here an empty container, and specifically we need to have this template reference variable, and I named it lazy content. First, let's see how things work. The first thing, do you remember previously that we said that we have a compiled component stack? So this is the compiled component stack. I didn't find a better image for this one. So imagine that this is the place that we have all our compiled components. In order to dynamically create a component, what we should do is resolve by type. Do you remember previously that we said about the type? So this is the type that we have here, and it's very important to have it. So we are resolving by type, and as soon as we have the compiled component, we are creating the component, and voila, we have it in the browser. So these steps, resolve by type and then create component, are two different methods that we programmatically invoke, and we will see how to do this. And this is how the code looks like. Very simple one, and we will start from top to bottom. The first thing is that we need to have a view child with a template reference variable. I named it lazy content, and this is what we have. And definitely we need to have this option here, read view container ref. As soon as we have this, the steps are two different steps. The first one is resolve, and the second one is create, right? So what we have to do is resolve, and the complete method name is resolve component factory, and we have to provide the class name here. That's why it's very important to keep in mind the types. So resolve component factory by the class name, and as soon as we have this, then we can create the component. And you might be wondering here, when we create a component, where are the components being created? in the container, and the container is what we created here. So let's have a look. Allow me to switch branches. First, discard everything here, and I will switch branch, and I will go to lazy or dynamically create components. Yeah, this is what I want to use. Again, let's start from the lazy wrapper. And it seems now that we have more code. Let's see what we have. We have the view child, which is the lazy content. And as said, the lazy content is a template reference variable here. We have the option read view container ref. And then, of course, we have to inject the component factory resolver. And we need to have, in any case, we need to have a condition. And the condition is like, if the component type is lazy, I want to resolve this component. Otherwise, if the component is lazy1, I want to resolve the other component. And in any case, we have to provide the class name. As soon as we have the component factory here, we can create the component. And let's see now what we have in the app module. We have in the app module, in the declarations, we have the lazy content component and the lazy1 content component. We no longer need to have the enter components. This is something that we used to have in the view engine. So let's see what we have in browser. In any case, I just kill the server and rerun the server. This is not needed. It's more like an OCD. So let's wait some time. And let's see what we have in the browser. Nice. So if I click load the first, what we can see is that we have, this is the content of lazy1 load component. And if I click load the second, we have the green one. Let's go back to the code and see the app component HTML. The only thing that the app component HTML does is that we have two different buttons. And this is load the first and assigns the lazy to component load. And if we click the other button, load the second, assigns the lazy1 to component load. And in any case, we provide the component load into the lazy wrapper. And the lazy wrapper is this code that we saw. So this is how we dynamically create a component. Let's go back to the slides. And in this part, I lied to you. And what I said previously is that the solution is to lazy load a component. Of course, this is not how to lazy load, but this is how to eager load a component. I know. The recipe to lazy load a component is, again, to use the same ingredients, the view container ref to dynamically create a component, and to also have the ES6 import. So this is the secret part here. And this is the third part of this topic, how to lazy load a component. And what we see is the exact same template. We have an ng container, and we also have the lazy content, which is a template reference variable. And this is what we will use. First, let's see how things work. Now that we have the idea of lazy components, what Angular does along with Webpack is that it creates different chunks. At first, we have, let's say, one chunk, the main chunk, and now we have the main chunk along with different chunks. And if we have 5 different lazy components, we're going to have 5 different chunks, one per each component. Now that we have 2 different components, we have 2 different chunks. And having them, the next step is to import using ES6 import, or else to download the component in the browser. And please note here that the component should be compiled. Okay, so as soon as we have the compiled component, the rest of the steps are the same. We have the compiled component and we have to resolve by type. This is the compiled component, and then we have to create the component, if you remember, 2 different methods, and voila, we have it in the browser. The steps here are a bit different. So when we lazy load the components, the flow goes like this. We define the components are compiled in different chunks, and we do not have them in the browser unless we request them. So I request a second and I have it, I request a third and I have it. This is how the flow goes. And now let's see how the code looks like. The only difference here with the dynamically create component is that we need to have an import, an ES6 import, and we have to define the path of where the component is located. As soon as we have the result of this import, this one, which is a new variable, the lazy content component, this actually is an object, and in this object, what we have is the class name. And the question here is, what do we have to define in the resolve component factory? The class name. And how can we have the class name? Here it is. Here is the class name. So as soon as we resolve, then of course we can create. The steps are the same. Let's go to the browser, to the VS Code, and see a demo. So again, for this one, I will switch branches, and I will go to lazy load components. Lazy load components using a condition. Yeah, looks nice. So let's see what we have. At first, let's go to the app module. We do not have in the app module the lazy content component nor the lazy one content component. And the reason is that if we have it there, the components will be eager load, but we want to have them lazy load. So we shouldn't have them in the main chunk. Apart from this, then we have the lazy wrapper component, and we have here a condition again. And the condition is like if the component type is lazy or if the component type is lazy one. What should I do? In the first case, I have to load the lazy content component / lazy content component. Nice. So where is this located? Here it is. And how about the second one, the lazy one? I should provide the complete path. And here is the path where the component is located. So in any case, we have to provide the path, okay? So we have this path, and as soon as we have this, we said that this is an object, and inside the object, we have the class name, lazy content component and lazy one content component, respectively. So let's run the server and see what we will have. And also, what about the HTML? Just the lazy content here, no more than this. Give it some time. Give it some time. Nice. So we have it. Let me reload. And now I will open the developer tools and specifically the network. If I click the first one, load the first. So what we can see is that we have now something that we just downloaded the component. And if we see the component is already compiled. If I click the other one, load the second, again, we download the component, and this is a compiled component, very important that it's a compiled component. We have it here, and we can see the results in the browser. Nice. And if I continue clicking the load first, load the second, we no longer have to re-download them. They have been cached. Nice. So this is how we lazy load the components. And again here, so you know what? Don't you see a pattern? What we can see here is that we have lazy one. We have here lazy and lazy one. The same goes here and same goes here. So it seems that we have a pattern. And we have the exact same problem that we, with the problem that we continued, that we started. We said that we have an open-close principle violation, and despite the solution that we provided, we currently have the same problem. How about if we have to load many components? In the first place, we had the condition in the HTML. Then we had the condition in the TypeScript with the dynamically create components. And again, now we have the condition, and we have to revisit the same file, the same code again and again. The solution to this problem is to lazy load the components using a pattern. So let's see how things work. Before explaining how to load a component, lazy load a component using a pattern, something that is very important is the following, that Angular during the compilation does the following. Check that we have here an import and understands that we intend to lazy load the component, and is like, okay, I know what you're trying to do. You want later on to lazy load the component. So what I'm going to do as a framework, I'm going to create a chunk for you. can I resolve the path? Yes, I can resolve the path. Nice. So as soon as I can resolve the path, I can compile the component for you in a different chunk. So now let's again change a branch, and I will go to lazy load components with a pattern. Let me kill this. And what I'm doing here is the following. Again, I have the lazy content, I have the view container ref, nothing changed here. I have the component type with a union lazy or lazy one, nothing changed here. The thing that changed is here. What I'm doing in this line is that I'm dynamically generating the path based on the pattern that we saw previously, lazy or lazy one, lazy or lazy one, lazy or lazy one. So since we have a pattern, we can dynamically generate the components. The path. So let's end this serve here and see what the results will be. What we expect to see is an error, and I will explain why we have an error. Okay, nice. So this is an error, and it's correct to be an error type. This is a change in Angular 12. In previous version, this was a warning, but in any case, this is an error. And what it says is the following, that you are trying to load something, I cannot resolve the path, and I'm not sure how to compile the component. And it says that include in tsconfig via the files or include property the path of lazy content and lazy one content component. So what I'm going to do here is the following. I will open tsconfig, and in the include, I will right-click here, copy relative path, and I will paste it here. And I will do the exact same thing for lazy one content component. Copy relative path, and here we have it. Now, let's try to rerun it. And in this time, what we expect to see is to have two different chunks with names. This the reason that we have the fact that we have different names on lazy load component chunks is again a change with Angular 12. The previous version we had just 0 and 1. Nice. So what we can check here is that we have different chunks. Okay, let's go to the browser to see what we have. I will reload, clear everything, and click load the first. And this is the first one. Load the second, and this is the second one. Nice. So it seems that we managed to lazy load a component using a pattern. But again, in this part, we still have the same problem. And the problem is open-close principle violation. At first, we had a condition in the HTML, and then we had it in the tsconfig. Now, we do not have a condition, but in any case, we have to revisit the same file, the tsconfig app. We have to revisit it many times. So what I'm going to do is the following. I will delete this line, and I will replace this with this character, and the same here. Kill and reserve. And having this pattern, what we expect to have, we expect to see again in the output of ngserve to have two different chunks, and of course, to make the code work in the browser. Please make it work. And let's reload everything here, clear, load the first, and load the second. Nice. So since we have this code, now I guess that I can just copy the lazy one content, and I will name it lazy2 content. And I will also rename this lazy2 content component, and the same goes here. Lazy2, actually, I don't need to have the selector, but it's okay. And lazy content component. Nice. And of course, let's use this color here, lazy2 load component. Let's give it a try. And I will go to the app component HTML. I will copy, duplicate this line. Let's have also a margin right here. And the component to load is going to be lazy2. The autosave, reformat my code. So component to load is this one, and make it work. And let's go to the browser to see what we have. clear everything, load the first, load the second, and make it work nice. We have the lazy to load component. And this is actually how we can lazy load a component using a pattern. And you can even simplify things here by removing the component factor resolver completely and be like, okay, I no longer have this. So I do not have this here, but in any case, I'm going to have this, the component class name. I will declare a property here, and the type of this is type, a generic of any. Let's also import this from Angular core, and I'm not sure if this is going to work. If not, we will change the video a bit. So what I'm going to do now is to remove the lazy content template reference variable and replace it with entry component outlet equals to this, the component class name. And let's go to the browser to see what we have. Load the first, nice, okay, it works. Load the second and make it work. So what we did is that we managed to use the entry component outlet and get rid also from the boilerplate code. And yeah, so this is how we lazy load the components in different ways. So thanks a lot. I hope you enjoyed it.
Thank you, Fanis. Very nice ideas.
Thank you very much.
Okay, we have no questions, so let's move to the next talk for today. Oh, Fanis.
I have something to say about it. I definitely really interesting. I learned a lot, Fanis, and funny that you presented that today because I actually built a library to do this, but did a one step up. So I built a library that allows you to configure lazy loading modules and components with dependencies through observables. That's set up similar to how like the router's set up. I can paste the link in the chat so you guys can check it out.
Nice.
But we actually use it in production because what we found was we ended up having this like really big mat stepper. You know, as you're talking, like once you get lots of components, you have like all these components in your tree, et cetera, right? So what we did is I built this library that allows you to define this like manifest of lazy modules with a component to render within that module. So you can define your dependencies that each of those lazy components have so that the compiler is happy and Angular is happy and it knows about all the stuff that you want to use. And then you just like switch map that through any observable in your application. So we do it off of a query param, I believe, but you can do it off of store values, you know, activated route, any observable in your application. Yeah, I was actually on the Angular Show podcast 2 weeks ago talking about it as well. So that might be of interest to you guys.
Nice, it sounds very good.
Yeah, so I'll paste the link in chat just so you guys can have a look at it. And the library seems to be working. We use it in production for, it's got to be coming up on 6 months now. So we're really enjoying it. I'm always open to having new things added to it. I didn't know about the template string import. I thought you couldn't do that. Excuse me. I feel like I tried and it didn't work, and so I gave up. But it's cool to know that you can actually do that.
Nice. Happy that I provided something into you. So I will definitely check both the talk and also the package in NPM. Awesome. Super.
Sweet. Cool. Thanks.
Great. I will share your links, Jay, to the public chat on YouTube.
Awesome.
Okay, we got 2 questions in the meantime. So first is, could you describe the real world use case where you use this sort of lazy loading?
For simple presentation components such as data chart, it could be something like this for presentation components, but you can have even more complex components here, and which they might have also a dependency on other modules. And in order to do this, you have to use, how it's called, the acronym, single component Angular SCAM, single component Angular module. So it's not only for presentational, you can have more components, but in terms of presentational, what you can do is, for example, to have a wizard. And in the wizard, what you have, different steps, step 1, step 2, step 3, and so on and so forth. So each step could be like a lazy load component. This is one use case. Another use case is, like you said, to have data charts or to load, I don't know, what you see, what you get editor, a big one. So lazy load one component and lazy load everything at once.
Yeah, what we use it for in our production app at Trellis is we have a side nav that opens up inside of our website builder. And inside that side nav, there's all your main menus. And then all those main menus have sub-menus. And every time you navigate to any of the sub-menus, the query prem will change and it will lazy load the new component into that side nav, because that side nav is just ng component outlet, like Fanis was talking about. So there's definitely a lot of real world use cases for it.
Exactly, there are many use cases. So as soon as you you have your hands dirty, let's say, you will find out that you can utilize this kind of technique in many different ways. So I hope this answered the question of, yeah.
Yeah, so the second question is, what about components with modules and its dependencies?
Yeah, this is a very good question. I can very quickly present this. So I will share once more my screen. So share screen, and yeah, this is the screen that I want to share. So say the following, that we have the lazy content component, and we want here to have, for example, a username control equals to new form control. And we all know that in order to use this, we have to import Reactive Forms module. So what we can do, so I will go to the app module, copy and paste this code and paste it here, just to have like the scam. And I will name this lazy module. I do not want this one, nor this. But what I want to have instead of browser module is to have the Reactive Forms module. And in the declarations, I have to provide the class name of this component. And of course, let's also import the ng module. So by doing this, what we are going to download is we are downloading the module and the component as well. So let's give it a try. Of course, we have also to have it here in the template. And I'm going to create an input type equal text. And the form control for this form equals username control. And to make sure that everything goes well, just interpolate the username control value. And sometimes I hate live coding, but sometimes it's okay. So let's hope that this will work. No errors. Nice. So this is how we have a lazy load component along with a module. And in particular, now we have Reactive Forms module. And this is how we achieve this with SCAM. This is it's called SCAM, Single Component Angular Module. I hope this answered the question.
Okay.
Okay.
If we have no more question, let's move to the next topic for today. So Jay will share with us more about using NGRX with Angular Universal.
Awesome. Thanks a lot. Okay. Share my screen. My presentation's not quite as nice as Fanis's, unfortunately, but it'll do. Okay, can we see that?
Yeah.
Okay. So today we're going to talk about rehydrating NGRX state from Angular Universal. So this is when we are doing server-side rendering all the way down to when we do the client-side rendering side of it. So who am I? I'm the co-founder and CTO of Trellis.org. We're a social enterprise and an all-in-one fundraising platform for charities and nonprofits. I'm an open source contributor, and some of my favorite projects are Nest, NX, and NGRX. I helped author a book on Nest.js, and I'm working on another one right now for building production level code bases from the ground up using NX. I'm also a bit of a beard aficionado, so as you can see, I've had varying lengths of beards over the years. Okay, so before we get into it, some terms and definitions, just because I know some people might not use some of these things, and I'm going to use these throughout the talk. So when I refer to universal, I'm talking about Angular Universal, so specifically the ng Universal packages and the @Angular Universal package. Universal is Angular's server-side rendering, so that on your server, you can render a static page that will be served to the client quicker, and then the dynamic version of your Angular app is loaded in the background. Now, SSR, server-side rendering, is different than pre-rendering. We're not talking about pre-rendering here at all. We're just talking about server-side rendering. NGRX, I'm going to refer to NGRX, but what I'm actually talking about is NGRX state. NGRX is kind of the all-encompassing reactive library for applications. State is specifically what we're going to be talking about, which is the state management solution that this topic is built on top of. We're also going to be talking about some meta reducers. So what a meta reducer is it's a hook, which is essentially a function that can hook into the normal application reducer flow and do some processing prior and actually after reducers are called, but it's always before the effects are called. So it's kind of like you can intercept and change your normal action reducer flow using meta reducers. Then we're going to be talking about serialization and deserialization. So in this talk, this is just referring to the process of converting data to and from JSON, just because we can't directly transfer JavaScript objects from the server to the client. We need to convert them to JSON, transfer them, and then convert them back into the JavaScript objects. And then rehydration. So this is the process of restoring the data from one state to another. So we're going to rehydrate our serialized data or deserialized data from the server once we get to the client. So why would we want to rehydrate the NGRX state? Well, one, we'll reduce the amount of computation on application load. So let's consider a lot of this is going to be happening on the main thread, right? And the more that happens on the main thread, the slower it takes for your application to load, and the slower everything else happens. So think about if you are rendering your application on the server and you have, 10 or 20, whatever number of actions that happens. Each of those actions could potentially alter your application state by running reducers, right? If we rehydrate our NGRX state and set up our app correctly, those actions happen on the server, but then the result of those actions are rehydrated on the client and they aren't rerun. That means that processing is not happening. We're not altering our state one action at a time. And we can also skip API calls. So we don't need to make that extra call to the server to get data because that data was transferred to the server and it was rehydrated. We can also reduce change detection cycles. So at the worst case, every time you update your global state, you're going to break your state's memoization. And that's going to cause a change detection cycle. Obviously, there's a big asterisk here because it depends on how your app's set up, what change detection system you're using, how you're asyncing your data around, et cetera, et cetera. But generally speaking, you'll have 1 to n updates based on the number of actions. And all of those are going to cause memoization breaks in your state, which increases your change detection cycles. So by rehydrating your state, you only get really the one change detection cycle, which is the initial, here's your state, reducer fires, updates, and your application renders. And then, of course, more actions might happen afterwards, but those are the actions that would have happened after your rehydrated state is put into your client's application state. So the normal universal flow, and this is very brief, there's obviously a lot more going on here, but generally speaking, what happens is the client will request a web page from the server. The server will render that web page. It will return the rendered web page, which is just a static site at this point, displays the static site to the client, bootstraps the dynamic app in the background. So this is your full Angular app once it downloads all of the assets. And then it swaps the static app for the dynamic app. in the background so the user doesn't actually notice this process happening. So this is how it normally works. But if we look at it with the rehydration, what happens is the client requests a page from the server will render the page, and at the same time as rendering it, will serialize the state and store it in the Angular's transfer state, which is a package provided by Angular to transfer data from Universal to the client. It will return the rendered page, display the static page, bootstrap in the background, and then it will deserialize and rehydrate the state during application startup init time, and then it'll swap the static site for the dynamic site. Once it switches over to the dynamic site, it already has a state, so it doesn't need to rerun all those reducers and actions and change detection and all this kind of stuff. So what exactly is happening, you ask? Well, we kind of just talked about it. The Universal server gets a request to render a page. Usually this is an Express, like a Node.js server or an ASP.NET server. I know there's other options, but I've only ever used Express. The Universal will spin up a fake DOM. Currently, this is using Domino, but I believe there's an experimental version using JS DOM, which will be released in the future. A meta reducer will serialize the state as it comes through. So on every action, it will process the new state and then serialize that. Universal will build the static page, and along with sending that static page to the client, it will also send along all of the transfer data. The browser will then render this initial static page. Angular will bootstrap the dynamic page in the background and hot swap it so the user doesn't notice. And then during the NGRX stores init time, there's actually an action that's dispatched. We will deserialize our state, which is pulled from the transfer data, and then merge that back into the state that's returned from the init action, so that our application starts up with the same state that it was rendered with. So note on serialization here. Some things in JavaScript are not serializable, such as functions, and your serialization process might fail if you're in Universal and your state contains non-serializable objects or data. There's two things you can do about this. You can explicitly exclude the states that you know aren't going to be serializable, like if you absolutely need to store a function in your state or some other non-serializable type data, you can exclude that. Or what you can do, if you know you will never have non-serializable data in your state, is you can enable the runtime flag for NGRX called strict state serializability, and that will tell NGRX to not save any state into your application state that isn't serializable. So it'll actually just error, and then you won't be allowed to do it. So that will ensure that your state is always serializable, it can always be transferred, and you won't have any issues with rendering your Universal web page. So let's take a look at a demo quickly so we can see how this is working. So what we have here is just a super basic website. I think it pulls like 100 records from an API that's running in the background. It just 100 strings, which is just a Unix state time. This is currently using Universal, so the initial request is we'll ask the server to render a new copy of the static page and then serve it, and then we're going to use the Redux dev tools, which you can see here, to see the app actually start up with the data in it. So we'll just refresh. Page is refreshed. We'll take a look at the two actions here. If you've never used the NGRX store dev tools, I really suggest you do. You have to import it in your app module, and then there's a app on the Chrome store. I'm using Brave. You can also install it in Brave. I'm assuming it's the same for other Chromium-based browsers. But it'll actually give you a history of all of the actions that are dispatched and their state prior, the diff, so the state after, and then what that action entailed. So what we're going to look at here is the NGRX store init. Oh, we're already on. Okay. So the action itself, there's nothing there. NGRX dispatches it itself, nothing really special. But we'll take a look at the state, and you can see that our items, they're already in the state, right? Because those items were transferred from the server, and during that init meta reducer, we told NGRX, okay, well, you're dispatching this action. Well, I'm going to do a little bit of altering, and the result of this action is going to be this. So now our app rendered with this data in the store without needing to make another API call to get that data. So let's do a little bit of a code review and step through just to see what's happening here. So this is the universal side of the NGRX metadata, or sorry, not metadata, meta reducer. In the library, there's two meta reducers. There's one for the universal side and there's one for the client side, because one needs to serialize and one needs to deserialize and rehydrate, right? So key things to note here. Meta reducers are called on every action that is dispatched through your application. You don't use the on function that the NGRX state or store exports like you would with a normal reducer. This is similar to how you used to write reducers when you had one function that had a big switch map in it. So what we're doing here is creating a meta reducer for use on the universal side. This code will never be executed on the client. That's a different meta reducer. So we are doing our processing after allowing the original meta reducers or the original reducer to be called. So what's happening here is the state at meta reducer time is passed in. The action that is triggering this meta reducer is passed in. We will call the reducer that would normally be called. And then after that's done, so that we have the new state rather than the old state, we're going to persist that to the transfer state, so that when the page renders, that data will be sent with it. We can serialize certain slices of the store, or we can just serialize the whole store. And we'll see how to configure this in a couple of slides here. You're probably looking at this and it's not super optimized. I haven't quite figured out the best way to do this yet. So open to ideas there. The NGRX Universal Hydration Service, it's just a wrapper around the transfer state that Angular provides itself, so that it just wraps it and serializes the data itself. So you don't need to worry about any of that stuff. You can just assign the new state to the service. So the browser side NGRX meta reducer now. So this is the one that happens on the client. This code will never be executed on the server itself. We check the action type for init. That init action's only ever called once. So this code will only ever be executed once. Otherwise, it just passes it on to the normal reducer that would be called. And what we're doing here is we read the state in from that hydration service, which again is just wrapped around the transfer state. So that's what's actually transferring our data. This library doesn't transfer the data itself. We're using the internal built-in Angular mechanisms for that. And then we can choose what kind of a merge strategy we have going on here. So we can either overwrite the entire store. We can merge our data over what would be in the store. So say if you had app reducers set up with initial data, we could merge ours over it, or we can merge it under so that the initial data overwrites ours as long as they're the same key. Your case might be different. I believe the default is overwrite, but configurable. So how easy is this to set up in the app itself? Well, it's as simple as adding the NGRX Universal Rehydrate module and calling for root on it. So if the store's array is left empty, then the whole store is just serialized. If the store's array has any values in it, the code will try and just pull those slices out of the store and only serialize those ones. So that's what that reduce in the prior slide was doing there. Note, remember to add the runtime check for strict state serializability so that this doesn't break anything else. What we're looking at here in the NG module is kind of the minimum stuff you're going to need to get this working. You need the browser module with the server transition if you're using Universal, setting up the store module, the title, state and title reducer, that is just the reducer, that's just the state that we're transferring. Yours will be different and it can be anything. The effects module is not needed. I'm just using it there because the data is pulled from an API. So we have an effect that pulls it. It's just that effect's not called on the client, it's only called on the server because we know that we're transferring it. There's store dev tools. You don't need them, but again, it makes everything easier to debug. The browser transfer state module, that's needed so that we're able to deserialize that transfer state data so that we can rehydrate. And then just the HTTP client modules. Again, those aren't needed. I just have them there because of the effect that pulls the data from the API. So what's not supported out of the box? If you're loading data from an API on page load or from other actions being triggered and stuff like that, this library will not handle not recalling those on a client for you. It's up to you to determine what actions need to be dispatched when and what ones need to be skipped on the client. All this library does is rehydrates the state that was transferred. In this sample app, which I'll provide a link to at the end, you can see how I'm doing it. I just have a check on is it in the browser or not. If it's not in the browser, make the API call. If it is in the browser, don't make the API call. Super rudimentary. It works for the test case, but in a real case, it might be more complex to know, like, okay, is the data loaded? Yes. Okay, don't make any API calls. If the data is not loaded, you do need to make the API calls. What state has been transferred, what wasn't transferred, and all that kind of stuff. So a more explicit logic is needed there, just because this library doesn't assume anything about that. And then you can't currently supply custom serializers for the state yet. With the JSON stringify method, I know you're able to provide a custom serializer or stringify function. Currently, the library just uses what's built into the Angular transfer state for that. Yeah, so pretty quick today. I know I kind of ripped through that. I was meaning to go a little bit slower, but if you have any questions, comments, concerns, or ideas, now would be the time. I'm really open to improving this, and I know everybody always has stuff to share. So if you want to reach out to me, my Twitter's there. There's a link to the package, and then the source code is there as well. In that repo, there's also a demo app, which is the one that we're actually running here, so you can see it running yourself. Yeah, so if anybody has any questions, then I can take them now.
Thanks, Jay.
You're welcome.
Okay, so if anybody, okay, here is the question. Does feature module with NGRX require more setup to rehydrate it?
So no, you can just define your feature slice in that original for root. I also believe that, oh no, I haven't set it up yet. I have a branch working on it right now to support for feature on the NGRX Universal Rehydrate module as well. So you can add those alongside all of your other feature modules. I just don't have it working quite yet. It's a little bit weird in some places, but that's definitely a feature that I'm supporting. If you use an empty array for your stores in the for root, all of your feature modules that get registered will be transferred. And if you know what your feature module features are going to be ahead of time, like what the state key is, you can add those to the root module stores array as well, and it will serialize them. So no, all of your feature modules that do get registered will get transferred out of the box.
Great. So we have no questions more. And okay. Thanks again, guys, for the great presentations. And I hope that all the people really enjoyed as me. And we can finish now today's meetup.
Awesome. Thanks for having us, Marco.
Yeah, thanks for having us. Jay, I will definitely have a look, and most probably, maybe I will contribute in some of yours.
I would love that. Feel free to reach out if you have any questions.
Yeah, looking forward to.
Sweet. Awesome. Well, nice. I hope my shirt shows up soon. my Angular Belgrade shirt, so I could be just like you
Yeah.
guys.
Exactly.
Awesome.
Okay, nice.
Great.
Awesome. So,
Thanks
Marco,
everyone for. Sorry.
thanks for everything, and thanks for organizing this and make it happen.
Yeah.
Thank you too, guys,
Great.
for the accepting my invitations and for really nice presentation. I learned today several things that I didn't know, so very cool.
Awesome. Anytime.
Awesome. Nice.
Yeah. And thanks everyone for watching us, and I hope that we will see you soon. Bye bye.
Okay.
Bye, guys.
Thank you. Bye.
Yeah.